So now I want to take some time to talk about Consul. Consul is our service discovery tool. And the challenge in talking about Consul in some sense is that it does so many different things, right? So when we talk about it being a service discovery tool, what does that really mean, right? In some sense, our goal is to provide a toolkit of features that really solve all of the different aspects that you really inherit the moment you go to a service-oriented or microservice architecture. The moment we go from one to many machines, now we have a service discovery problem. How do we actually know where our upstream services are running? We have a health checking problem, because now that there's many upstreams, some of them may not actually be healthy. We have a configuration problem. How do we configure our many different services? We have a coordination problem. If we want to run multiple instances of a service for availability, and one of them fails, and we want another one to take over, we need distributed locking tied into health checking, tied into discovery. So the list of kind of things that Consul needs to support to really effectively be able to solve this service discovery problem is broad. And so what you'll end up seeing then is a huge set of features and capabilities that we're constantly adding to support this. So this is just a small preview of all the things that Consul has gained in just the last year. And one of the things that's always been super important to us when we thought about Consul, when we first built Consul, when we designed the system, was realizing that because of the role it plays, because you're depending on it to do this service discovery, this health checking, this configuration, it acts as kind of a dial tone to the data center. All of your services are using it to look up their upstreams. Health checking is being used to do automated failovers. And so it's very, very sensitive. And if it takes down, it can have a lot of collateral damage to your data center. And so from the very beginning, it was important to us that the system be rooted in academic research, and that we're really delivering a world-class, state-of-the-art system to make sure we're giving you the highest level of sort of availability and performance and ability to tolerate failures. And so there's really two very important subsystems. One is Consul's gossip subsystem, which allows it to scale linearly to data centers with thousands of nodes and effectively be idle. And this gossip subsystem is based on a work called SWIM. The other really important subsystem is its consensus and replication system. This is based on Raft, which is simplified Paxos, which is a consensus algorithm. And so what this lets us do is replicate Consul state between multiple servers and gracefully handle the failure of any of those servers. And so this lets us give you these guarantees that the system will both scale and stay online. So in the last year, we were really excited when we announced the launch of HashiCorp Research. And our goal was to really recognize that we consume a lot of this research from academia and use it to build our products. It's at the heart of many of the tools we build. And so we wanted an opportunity to give back as well. We wanted to be able to do our own novel research into algorithms, into system designs, into empirical analysis of what we're doing with these things, and then publish that and give back to the community that we owe so much to. And so I'm super excited that in the last year, we published our first ever paper. We call it Lifeguard, Swimming with Situational Awareness. You might claim we got a little overly clever with it, but we had fun with the title. The core sort of inspiration of this was really actually working with one of our largest users who was experiencing a denial of service attack. So they were under a denial of service, and their front-end machines were getting just totally slammed. And then they noticed that for whatever reason, random machines that aren't on the front end, Consul's declaring as failed, right? Machines that are not publicly accessible to the internet, that are not affected by the DDoS, are just being marked as offline, but are being marked as failed. And so this was a really interesting opportunity for us. And so they brought us in and worked super closely with us and gave us access to their environment to really understand what's going on under the sort of pathological condition of the DDoS. And what we found is there was a number of shortcomings in the underlying gossip protocol, that it made certain assumptions that under cases like this, where some nodes were heavily degraded, would degrade the entire cluster's performance. So we worked with them, and we worked internally with HashiCorp Research to come up with a number of novel extensions to the way SWIM actually operates to work around these issues. And the results are kind of amazing, honestly. They beat even our own expectation. What you can see on that graph is basically sort of the baseline system on the left, which is pre-Lifeguard. And just by enabling Lifeguard, no other changes, no other configuration to the system, we see a 98% reduction in the rate of false positives in the system. And so this was kind of crazy for us, because some of our customers run data centers with tens of thousands of nodes, hundreds of thousands of Consul agents in a single cluster. And so this 98% reduction for them is huge. Consul basically goes completely quiet in terms of flapping. And so we were able to take some of this benefit, some of this sort of 98% reduction, and actually tune the system to not only have a dramatically lower rate of failure detection, but also to detect failures even faster because there's so few false positives. So we're super excited about this. Our director of research, John Curry, is here. He's going to be giving a talk about Lifeguard. So if you're interested in the nitty-gritty of how this actually works, please make sure to attend his talk. One of the things that sort of come from this relentless focus on operational stability and scaling has been that we've seen an incredible amount of adoption for Consul. Right? It is now deployed in some of the world's largest video streaming companies, some of the world's largest financial institutions, some of the most trusted news sources, and some of the largest consumer tech companies. And partly it's because of this focus, it's the sort of relentless polish we put into the system so that it actually works at their scale. And this has not been overnight by any means. Consul has had a long, long history. Many of our earliest users have suffered through some really atrocious bugs, and we apologize. And we've come a long way since then. And so this has been a slow and steady but relentless march to improving the system. I think many of you probably know where I'm going with this. And so we're very, very excited today to finally announce Consul 1.0. It was really only now it's our third product. Vagrant actually just got to 2.0 in the last 2-3 weeks here. But it just joins Vagrant and Packer as HashiCorp's only 1.0 products. And for those of you who've never had a chance to sort of read up on our philosophy of it, it's not because our tools aren't used in production. It's not because they don't see scale. It's just that HashiCorp holds such an incredibly high bar for what we're willing to call a 1.0. We really want to make sure we understand what is the total surface area of the use cases? How are people using this thing? Does it work even at these most massive scales? And make sure that it reaches our level of fit, finish, and polish before we put that 1.0 label on it. So rest assured, this is not an end-of-lifing announcement for Consul. There is a long roadmap ahead of it. Sometimes it just takes us 4 or 5 years to actually get there. So Consul 1.0 is going beta today. It's available. Download it. Check it out. Let us know if there's any last-minute issues before we take a 1.0 Gold Master.